Welcome to this session on creating a curved polygon grid. So in this session, we're going to take our curved facade and we're going to break it down into a grid of polygons. Now there are several ways we could break this surface down into a grid of points. We'll start by using UV parameters on a surface. So this is similar to placing a t value on a curve, only we're placing those t values in two directions, the u and the v direction of the surface. So I'm going to go over to my node types. And I could do this with points or coordinate systems. I'm going to use a coordinate system because, again, it gives us that added value of having directions and planes that we might use for other geometry. So I'm going to go ahead and drag and drop a coordinate system onto the graph. I'm going to rename this as the facade CS. If I look at the techniques, there is a technique which is by UV parameters on surface. So this requires a surface. We're just going to use our atrium surface. And rather than look for the node on the graph, you can always put your cursor in the field and then simply select the surface from the model. And it fills in the field there. And then we just need to create the t values for the u. So for instance, if I simply put 0.5 in here and I put 0.5, I would get 1 point that's essentially the center of the surface. Now that's the center based on the curve. It's not necessarily the dimensional center, but it's based on the way that points are placed along a curve. So if I used a series here rather than a single value, I would get multiple points in each direction. So I'm going to simply do a series that starts at 0, goes to 1 with an increment of 0.1. And we'll close that. I'm going to use the same on the V so I can copy and paste. And you'll see I've got now a diagonal set of points across that surface. And we should remember from previous sessions that that has to do with our replication style. It's currently set to the parallel or corresponding indexing. And if I right-click on the node, I can switch the replication style to all combinations, and then I will get the full grid of points. And that grid of points could then be used to create polygons. Now, one thing to note is that our points don't necessarily line up with our floor lines. So when you place points using the UV parameters, the points are going to be further apart where the curve is shallower, and they're going to be closer together where there is a more extreme curve, which means that our points aren't going to necessarily be equidistant apart. They may not line up with our floor lines. And so this may be an issue in terms of how you want to construct the curtain wall or the glazing that would go on this facade. So we could look at an alternative way of creating a grid of points here. So we do have arcs that created this surface that appear at every floor line. So I could potentially use those arcs to generate the points, and I could simply change my technique here from UV parameters on a surface to by parameter along a curve. And then use the arc atrium curves. And I could use the same series, so 0, 1, 0.1. Now I get 10 points along the curve, or at 10 spaces, but they line up with the floor lines. If I were to look at my front view, I can see those points are horizontally aligned with my floor lines. And that might be a better scenario for creating the glazing that would go on this surface. So I'm going to go ahead and record that transaction. And now I'm going to use those points to create a grid of polygons. So I'll come back to my node types and I'm going to select the Polygon node, drag and drop that onto the graph. And I'm going to rename this as a polygon panel. And we're going to use the technique by point grid. Fairly simple. We've got a nice point grid, and all we have to do is link this node to our point grid, and we now have a series of panels. Now, interesting to note, I'm going to look at my inputs here, and there are some other options that could be set. One is the facet option. So if you'll notice, by default it's quads, so we're getting basically quadrilaterals as our panels. Important to note though that it doesn't mean those shapes are necessarily planar. If I were to select the option which is to force planar quads, kind of zoom in here, you can see what happens when we force those quads planar. I'm going to end up with gaps in the curtain wall. So it creates a plane with 3 of the points, and then the 4th one gets projected out in order to maintain a flat plane. On the other hand, another option would be to triangulate, and there's several different methods to triangulate. We'll just look at the triangulation alternate. So whenever you triangulate panels, they're going to be planar, but of course then you're going to end up with triangles, and we could create panels that worked with that, and at least everything would close. But we're going to go back and set this back to quads. We'll just let them be non-planar, and we'll account for that when we do create the curtain wall node that we're going to add to this. And of course we could put some family and part information on those polygons. So again, I might select the curtain wall glazing part and go ahead and put some transparency on that again, just as we did on the surface. And I could go back and turn off the surface so that we only see the polygons. Now in the next session, we're going to take a quick look at fabrication planning so we could see how we could take that curved facade with polygons and basically unfold it so that it could be printed in a 2D format and then reconstructed as a 3D model.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.